Hi, I'm going to be talking about calorimetry today, and for its general description, I'll give its most basic definition, as it's the process used to determine or to measure heat absorbed or released during a reaction. It helps experimenters determine whether a reaction is endothermic or exothermic, and we use the temperature change of the surrounding environment of the actual reaction to determine if it's exothermic or endothermic. So some possible uses for it, kind of mentioned this before, but it's basically we're trying to identify whether a reaction is exothermic and endothermic and determine how much heat is being released or absorbed by the reaction. This falls really under the realm or in concept of thermochemistry. So I can kind of give an example of like how someone would use it. Let's say for a reaction, you're trying to find the total enthalpy of a whole reaction with multiple molecules and components to it. So let's say sodium chloride, NaCl, is part of the reaction, and you need to determine its heat of formation and how much energy it releases when it either absorbs or breaks. So what you can do is you can place NaCl inside the cup, which already has a solvent in it, and basically you let the NaCl dissolve inside the solvent. For most of our cases, in experiments, we use water as a solvent, and you take the temperature of the surrounding environment, being the water, and you determine if it's endothermic or exothermic. So to kind of provide some more details on how it works, essentially for our experiments, we used a styrofoam cup, and in that cup there was a constant pressure and constant volume. We placed the so-called system, or the thing that reacts, inside the water, which is again the solvent. We also place a thermometer inside the calorimeter cup, and for the whole time, because we're trying to gradually take the temperature of the environment as the system dissolves in the water. If the reaction is exothermic, the temperature of the water will increase, and if the reaction is endothermic, the temperature of the water will decrease. And we kind of have to remember that the system is what is losing or gaining heat, and we're taking temperature of the surrounding environment, so that's why that happens. Some tips and tricks to contribute that can contribute to efficiency and safety. A lot of times we put a lid on top of the cup to avoid possible systematic errors in which temperatures from the environment can affect results. Also making sure to pour contents inside the cup quickly to avoid it being exposed to the environment too long. And lastly, to account for heat transferred, we have to account for heat transferred to the cup as well from the reaction. And a double layer cup is also great to use because it provides extra insulation. Thank you.